Here we go. In this video, we're gonna learn about Floyd-Warshall algorithm. So before jumping into this algorithm, we make sure you have better understanding of Dijkstra algorithm. So be sure to check out that video first. But the drawback of Dijkstra algorithm is it will not work for negative edges. So for that we have Bellman-Ford. So these two algorithms is the prerequisite of Floyd-Warshall. So Bellman-Ford algorithm will work for negative edges. It will detect if there's a negative cycle. But these two algorithms will only work on single source. So we have a single source and uh, we want to find the distance for other vertices. But Floyd-Warshall will work on will consider multiple sources as a starting point, and it will detect the distance from every u to every v vertex. So from any given node to any given node, it will check. It will check for multiple sources. So let's find out and let's try to understand what Floyd-Warshall algorithm really is. So we have a question, Floyd-Warshall. The problem here is to find the shortest distance between every pair of vertices in a given directed weighted graph. It is represented as adjacency matrix, matrix ij, adjacency matrix, not adjacency list. The element denotes weight of edge from I to j. If there's a -1, it means there's a no edge. There's no edge, so we need to modify the distance in place. So you have given matrix as adjacency matrix, and we just need to modify the input array. First we have this. So this is our input array. 0 to 0, 0 to itself is 0, 1 to itself is 0, then 0 to 1 we have a edge, 0 to uh, so we have edge. So this is the adjacency matrix. So it means 0 to 1 there's a edge of 25, 1 to 0 there's a edge of -1. So output is same. Then if we have this, then we go to this. So let's pick this particular matrix. So what we got? 0 1 2 0 1 2. So we have 1 4 1 0 143 1 0 6 -1 -1 then 0. So we have three nodes. So 0 to itself, then 0 to 1 there's the edge, 0 to 1 with weight 1, then 0 to 2 with weight 43, then for 1 we have 1 to 0 of 1, then 1 to 2 with 6. So we have this, and in this case, in the Floyd-Warshall, in this particular thing, we don't have negative edges. But let me tell you, Floyd-Warshall will work for this algorithm. Floyd-Warshall will work for negative edges, and it can detect negative cycle. We will solve this that question also. So we have this question, negative weight cycle. We gonna learn how we can easily solve this question. So before that, let's focus on this particular question. In this, we don't have negative edge. Here, -1 does not mean an edge. It means just there's no edge between starting from 2 to 0. We don't have any edge. So now let's try to understand how we will update these. So what we'll do, we have to first we have to go from 0 to 0. No, we cannot go because 0 is itself. Then we have to go from 0 to 1. We have to go from 0 to 1 by taking 0 as middle. So um, our graph is very small, so it does not make any sense. So let me create a big graph so it will make a sense. So we have zero base indexing, 2, 3, 4, and let's say 5. So let me also give it a weight. So in this case we don't have negative weight, so let me give it a positive weight. So we have this is our graph, and we want to visit, we want to go from, first we will start from 0 to 0. So 0 to 0 is not possible because it is itself, so we will not go to that. Then 0 to 1, 0 to 1 by taking 0 as route, by taking a route of 0. So it does not make any sense. We are uh, going from from start to ending, from start to ending by taking a route as start. So it does not make any sense. We have a dedicated edge itself. So then we try to update this, so it will become 2, 3, 4. So then 5, 0, 1, 2, 0, 1, 2, 3, 2, 3, 4, 5. Okay, then convert it will gets convert into 1. So then we are trying from 0 to 1 to 0. We are going from 1 to 0 by taking 0 as route. So this will match, and our destination and middleware and our middle is matched, so it does not make any sense. Then 1, so it does not make any sense. Then it will go from 2. So now it is making sense. What thing we have to do? So let me also build this matrix. So let me build a matrix here. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So starting from 0, we have this value as 0. Then from 0 to 1, 0 to 0 to 1, no, we don't have. 0 to 2, yes, we have. So other values is minus 1 itself. Then starting from 2, starting from 1, 1 to 0, then 1 to 2. Then starting from 2, 2 to 4, 2 to 4, then 3, 3 to 0, 3 to 4, yeah, then 4, 4 to 4 to 0, 5. Starting from 5, we have only 1, 5 to 3 with weight 2. So now let's find out. So we are going from 1 to 2. So 1 by taking a route as 0. So what I will do is, I will first go from 1 to 0, then I will go from 0 to 2. So what's the value of 1 0? 1 0, 1 0, 12. Then can we go from 0 to 2? 0 to 2. Yes, we can go from 0 to 2. So the total value is 14. So if I try to go 1 to 2, 1 to 2 with the middleware, so 1, so let me change the color from 1 to 2 by taking a middleware as 0. So it will give me 14. It will give me 14. So 1 to 2, 1 to 2, here the value will be 14. But we want smaller value. Smaller value is there already, so we will not update. Then what I will do, I will change my destination So there's a loop. Then I will try to go I will try to reach 3. So can we reach 3? 1 to 0, 0 to 3. So 1 to 0, then 0 to 3. No, we cannot reach. The value present is -1. So can we reach 4? By taking a route via 0. So can we reach? So first I will go 1 to 0, then 0 to 4. 1 to 1 to 0, then 0 to 4. No, we cannot reach. So can we go to 5? 1 to 0, 0 to 5. No, we cannot go. So now I will change my starting position. 2. 2 to 0, it will match 2 to 1. First I will go from 0 to 2, then 0 to 1. 0 to 2, 2 to first, sorry, 2 to 0. So 2 to 0, we cannot go. So it will just continue, then 2. So it will match, source and destination is matched. No need to go further. Then I will try to go. I will try to reach. Starting is 2, ending is 3 via taking a route of 0. So first I will go. So it will look like this: 2 to 0, then 0 to 3. So first I will go to 0, then 0 to 3. 2 to 0, no, we cannot go. So 4 will also not work because 2 to 0 is not there. 2 to 5, 2 to 5 will not work. 2 to 0 is not there. Then what we have? 3. So I will start from 3 onwards. 3 to, I will try to go, I will try to reach 0, but 0 is matched. Then 1. Yeah. 3 to 0, 0 to 1. 3 to 0, 0 to 1. No, we cannot go. What about 2? First I will go from 3 to 0, then 0 to 2. 3 to 0, 0 to 2. So then I can reach 3 to 2. So 3 to 2. Yeah, we can reach. So this is our new point. 3 to 2. We can reach by taking a route of this. So what's the value? 3 to 0 is 9. This, then 0 to 2 value is 2. So the total value is 11. So to reach 3 to 3 to 2, we have to take 11. So the value will be 11. Then I will try to reach 3, but 3 is matched. Then 3 to 4. First 3 to 0, 0 to 4. 3 to 0, 0 to 4 not there. 0 to 5 is not there. So then I will start from 4. I will start from 4. Then 4 to, I will try to reach 1. 4 to 0, 0 to 1. 4 to 0, 0 to 1. Not there. I will try to go 2 to 4 to 0, 0 to 2. 4 to 0, 0 to 2. Yes, I can reach 4 to 2. So 4 to 2. Yes, the value will be 4. The value will be 4. So what's the route I am taking? First, I will go from 0 to 4 to 0, then 0 to 2. So this route, the total value will be 4. So I have filled 4 here. So then, can I reach to 3? Let's find out. 4 to 0, 0 to 3. 4 to 0, 0 to 3. No, 0 to 4 is not there, 0 to 5 is not there. So we cannot go yet. So 4 not there, 5 not there. So then I will start from 5. 5, and starting from 5, I will try to first reach 0, but 0 is our route and 0 is our destination. So it does not make any sense. Then 5 to 0, 0 to 1. 5 to 0 is not there. 5 to 2, 5 to 0 is not there. So it will just does not work. Then so for 5 to 5, I have already checked. I have reached. Then 5 to 6, I cannot make. Then what's the next step? Here I have taken a route as 0. Then I will take a route as 1. I will take a route as 1. Then 0 to 0, no, not possible. 0 to 1, not possible. 0 to 2, yes, let's find out. 0 to 1, 1 to 2, 0 to 1, not possible. Then 0 to 1 is not possible, then we cannot go further. So let's directly start from 1. 1 to 0, not possible. 1 to 1 is not possible. 1 to 2, not possible. So this is matched, so just continue starting from 2. 2 to 0, 2 to 1, 1 to 0. Let's find out. 2 to 1, 2 to 1, not possible. So 2 to 1 is not possible. Let's start with 3 directly. So 3 to 1, 1 to 0. Yeah. Uh, yeah, 3 to 1, 3 to 1, not possible. So we cannot go 3 to 1. So 1 to 0 not work. 1 to 2, 3, 4, 5, nothing will work if I have a root of 3 to 1, not work. So then 4, starting from 4. Let me erase this. Then 4 to 1, 1 to 0. 4 to 1, 1, 4 to 1 will not work. 5 to 1 will also not work. So if I take a route, nothing will work. Let's change the route to 2. So 0 to 0, nothing. Then 0 to 2, 2 to 1. 0 to 2, 2 to 2 to 1. So not work. 0 to 2, then 0 to 2, 2 to 3, 2 to 3, not work. Then this 0 to 2, 2 to 4, 0 to 2, 2 to 4. Yes, we can reach 0 to 2, 0 to 4. We can reach by taking this tens of 11. So as you can see, 0 to 4 by taking a route of 2, we have this tens 11. So just fill 11. So I hope you got it. We have a route. First we will start a route with 0, then we consider each and every vertex as our route. So I will write it like k. This is my k. So first k will work for 0 and k will reach till n. K is our route, via or route. Inside this we have a starting and we have a ending. We want to reach from every I to every j. So for every I start from 0 till n, then int j start from 0 to n. Inside this what we have, so I will write here, if and only if there's a route and our middleware, so I am reaching I to j via k. This does not, this have to be different if this is matched. So if I is equal to k or k is equal to j, our middleware is equal to starting, or our middleware, our middle is equal to ending. So it does not make sense. Or our I is equal to j, our starting is also equal to ending. So no, nothing will make sense. And we only consider this route if it's possible to reach from I to k and also I to k to j. If and only if we will consider this. So what I have to do? Matrix. So let's say I to k have to be some value, not equal to -1, have to be some value. And uh, if this is equal to -1, means there's no route. Or k to j, there's no route, -1. So just directly continue. We cannot go further. Then what we want? We want minimum value of I to j. We want minimum value. If already present value, So a of I j already present value, or we have first I to k, then I will reach I k to j. But there's a missing part. Initially, as we have seen, if there's a route and so we have taken this route, yeah, 0 to 4. So first I will consider this, I will consider this value present, fine. Then we are finding value 0 to 4, 0, we are going from 0 to 4. So we are updating value here. Initially what we got minus 1 here, we got minus 1, and minimum we are finding minimum, so it will just pick up minus 1, nothing else. It will just directly pick up minus 1. Minus 1 is the minimum, so we have to do something. We will just try to check if ij, we have not find any route, and this is the first time we are finding a route. So just update it with a positive infinity, so that afterwards, this is our first time we are finding a route, it will not pick up minus 1, it will pick up some other value. So we are comparing with infinity and some x, so it will pick minimum and it will give me x. So that's how the Floyd Warshall algorithm will work. It's a pretty straightforward algorithm. So let me show you the code. We have n, we have root, and we want to start from starting position and ending position. If starting and ending position is the middleware itself, is the middle route itself, and if there's no route from starting to middle and middle to end, so just continue. Else if this is the first time we are finding a route, just fill it with the positive infinity. So after that it will just update it, because in the input matrix we are getting minus 1 itself, so that's why we have to handle this, otherwise we don't have to handle this. So then uh, it will compare it and find the minimum distance, and if there are multiple routes it will pick up minimum route. So this algorithm will just work fine. So let's give it a hit, and let's talk about time and space complexity. In this particular function we are not utilizing any space, so it is constant. Time, we have three loops, same loops, so it will be n cube. Now let's solve our second problem. We have this, we have given edges list. So this question we have already solved using Bellman-Ford. So you can easily solve this question using Bellman-Ford. So you can approach it using Bellman-Ford or Floyd-Warshall. So I will link this question in the description box. So first of all, we have given edges list. I will not gonna spend too much time here. So we have given edges list. First of all, we want to build a matrix. So it will build a matrix. I have build a function, so it will create a matrix, and in this I am filling it with the infinity initially, and we have 0 to 0. So starting and ending is same. So I want to reach a node to its to a node to himself. So the distance is 0. Otherwise we are considering edge. Then we have shortest distance. Initially I am passing matrix and false. So checking is just for next shortest distance, is just for detect a cycle. I will tell you. So you can simply ignore checking initially. So simply ignore checking. Then after, so just simply ignore this, and everything else will just work. Then I am passing checking as true. So what it will do? In the next iteration, if there's a negative cycle, it will then update a cell. So I am checking if this is the return. If this is the return function, this is the return that we want to do. And if checking is there and the new distance we are getting is smaller So we are definitely sure there's a negative cycle. How we are definitely sure? So to make sure, you first have to watch the Bellman Ford, then only you will get this point. After uh, after iterating v minus 1 times, we are getting a negative cycle. We have to detect a negative cycle, only then we can detect. So that's why after iterating shortest distance for each and every pair, only then we can detect if there is a negative cycle or not. So if checking is there and we've checked there's a negative cycle, just return 1. There's a negative cycle. So just submit it and it will just work fine. Both problem and code is provided in the description box. So we make sure first, you himself first make sure to solve this question, then only um, see the solution. So I hope you learned something new. Give this video a thumbs up, subscribe to this channel, and thank you all for watching.